This video is about subnet masks. A subnet mask defines the boundary between the network portion and the host portion of an IP address. Understanding this boundary is the foundation of network segmentation, firewall rules, and routing, all of which are critical as you create your security posture for your networks. First of all, subnet masks are also written in dotted decimal notation and also consist of 32 bits, just like the IPv4 address. A subnet mask again answers that one question: where does the network portion of this address end and where does the host portion begin? Two devices that are on the same network segment can communicate directly with each other. Two devices on different network segments need a router to communicate. The subnet mask is what defines which side of that line a device is on. When considering this division, it helps to remember that the subnet mask is actually 32 bits, with individual bits being on or off, 1 or 0. The network division happens when the ones end and the zeros begin. More than that is outside the scope of this course. Again, it's much easier to deal with dotted decimal notation when we consider subnet masks. The most common subnet mask in OT environments is likely going to be 255.255.255.0. This means that the first 3 octets, or 24 bits, are all ones, and that identifies the network, or the first 3 octets identify the network, and the last octet identifies the host, giving you up to 254 usable device addresses on that segment. You may be wondering why you only have 254 usable addresses if the last octet can range from 0 to 255. The reason for this is that there are always a few addresses that are reserved within each network. We will discuss that more in a second. Here are a few more subnet mask examples. 255.255.0.0. This mask only uses the first 2 octets for the network, which gives you a much larger address space, right? The last 2 octets. A 255.255.255.252 mask leaves only 2 usable addresses, which you'd see on a point-to-point link between 2 routers. Let's take a practical example. Assume you have 3 devices. Device A at 192.168.10.25 with a mask of 255.255.255.0. It's on network 192.168.10. Device B at 192.168.10.40 with the same mask is on the same network and communicates with device A directly. Device C is at 192.168.20.10, and it's on network 192.168.20, a different network segment entirely. Devices A and C will need a router to communicate. This logic is the foundation of network segmentation. When you create VLANs in Module 4, you're creating separate subnets that require routing and therefore access control in order to exchange traffic. A minute ago, I mentioned that there are always some reserved addresses within a subnet. Typically, the first address is reserved as the network identifier, which routers will use to find your network. The last address is used as the broadcast address, which can be used to send data to all devices within your subnet simultaneously. A final address that is usually reserved is the second address within your network. It is reserved as the default gateway address, or the address that all hosts within your network should communicate with if needing to send traffic outside the subnet. Remember, our router. We'll talk more about this later. Next, we're going to look at private versus public IP ranges. Which addresses are used inside organizations and which are routable on the internet. That distinction matters for how you design and protect your OT network.